All right, guys. Hope you guys are ready to do some learning today. Today we're going to start talking about some two-step equations, but we're just going to focus on writing those equations. We're not going to worry about solving them yet. That'll be later on in this chapter. So let's go ahead and give this a beginning. All right, this is writing two-step equations is really reading a context or a real-world situation, a word problem, if you will, and turning it into an equation so we can find the unknown in the word problem. So it's always good to identify our parts first and then kind of put the equation together. So let's read this problem and identify those parts. This one says the length of an average toucan, that's a bird, it's a type of bird, is about 2/3 the length of an average blue and yellow macaw. Toucans are about 24 inches long. Write an equation to represent this situation. So let's just take this one little bit at a time. The length of an average toucan is about 2/3 the length of an average blue and yellow macaw. That's all. All of this is pretty much important. Toucans are about 24 inches long. Well, let's just start with we got two types of birds, right? We got a toucan here. It is so long. We have a macaw here, the blue and yellow macaw here. That's uh, that's going to be a certain length. So those are two things we're talking about here. Which of those is the unknown is the question. Well, let's see here. It says toucans are about 24 inches. But does it ever say what macaws are? It doesn't. So the macaw is going to be the variable in our equation. So we actually are given some other information here at the very beginning. It says the length of an average toucan is about 2/3 the length of the average blue and yellow macaw. So the toucan, we'll start with the toucan. The toucan is a key word in word problems that usually means equals. And toucans are about 2/3. That's 2/3, 2/3 the length of the average blue and yellow macaw. All right. So this equation though it kind of has two unknowns in it, but we know one of them. We know what the toucan is. The toucan is what? Toucan is 24 inches long. So let's replace that. The toucan is 24 inches long, and toucans are about 2/3 the size of a macaw. Okay, look at that. The quick, simple review of one-step equations right there. Again, we're going to just write equations. We're not actually going to solve them. Although you could solve this one right now. It's just a one-step equation. This is a multiply right here. 2/3 times m. To get rid of that 2/3, you have to divide both sides by 2/3. Let's take a look at one more example of one-step equations. And then, actually, this is yeah. Let's take a look at this one. This is another one-step equation. And just to review it, it says a zookeeper takes care of 5 mountain lions, and the keeper orders 32.5 pounds of meat for them each day. So all of these lions together eat 32.5 pounds of meat each day. That's quite a lot of meat. All right, so adding all of these lions' consumptions, how much they eat a day, ends up being about 32.5 pounds of meat. Well, do you know how much each of them eat? Neither do I. So I'm going to use a variable because that's an unknown. This lion here, I'm going to use a cursive L, eats I don't know how much meat a day, and we're just going to use that I don't know with an L. And so does this lion, and this lion, and this lion, and this lion. Altogether, they eat 32.5 pounds. Well, how many L's am I adding together? These are all like terms. That's 5 L's, or 5 lions here. And they all together eat 32.5 pounds. And voila, there's my equation. Again, you guys could probably solve that, but we're going to move on to two-step equations. Two-step equations are basically, it just takes 2 steps to solve the equation. These ones, like the lion example, take 1 step. and that is to divide both sides by 5. That's one step. Two-step equations, we haven't looked at how to solve those yet, but they're easy to write. We can still write those kind of equations. Let's take a look at our first example here. This is a photography student wants to buy a digital camera that costs $269.95. She plans to make a down payment of $100 and then pay the rest in 5 equal monthly payments. Okay, write an equation to represent this situation. Well, let's start at the very beginning. We know that the total cost right here is going to be $269.95. But we have some other parts of this word problem that need to be put into the equation. She's going to make one large down payment, so we know that the down payment plus these 5 equal monthly payments. Let's see, 5, wrong color. Let's make sure I get the right color here. 5 monthly payments is going to equal the total of the camera. Well, let's take a look at that. I'm going to break that up a little bit. Have the down payment. Do you know what the down payment is? Yes, we do. The down payment is $100 plus the 5 monthly payments. Now we're also told that these are going to be equal monthly payments, so this is going to be plus P. Make sure I choose green. Excuse my color blindness. P plus P plus P plus P plus P. Because I have how many monthly payments? I have 1, 2, 3, 4, 5 monthly payments. And that's going to equal the camera's total cost. So I got the down payment plus the 5 equal monthly payments. Again, let me share that with you. This is going to be the first month payment, the second month payment, the third month payment, the fourth month payment, and the fifth month payment. We can simplify this, though, by combining like terms. It's going to be 100. Man, can't see color. It's going to be 100 plus 1, 2, 3, 4, 5p equals 269.95. Look at that. We have an equation. We can't combine any like terms over here anymore. There's nothing to simplify on either sides of this equation. So there's my equation. All right. Why don't you go ahead and try this one out yourself? Draw pictures. Remember, identify the parts of the expression of each side of the equation. And I think it's going to help to draw pictures on this one. So go ahead and pause the video. Give this one a shot. All right. Upon the first read of this, it says an orange grower ships oranges in a box that weigh 10 kilograms each. What weighs 10 kilograms each? That is the box. The boxes that these oranges are shipped in weigh 10 kilograms each without any oranges in it. Okay, so I have a box. I'm a horrible artist, so I have a box, right? And you can throw things in this box. In this case, we're going to throw what in there? We're going to throw oranges in there. All right. Each orange weighs 0.2 kilograms. I have to apologize. I'm going to use red. I think this is red. That it would be green. I'm going to use red for our oranges, so bear with me. I've got oranges, right? Oranges weigh how much? Oranges weigh 0.2 kilograms. Boxes weigh 10 kilograms. All right, the total weight of a box filled with oranges. So I got to take a bunch of oranges and throw them on into the box. That's going to give me a box full of oranges here. Oranges galore. Lots of oranges inside my box now. How much is that going to weigh? Well, it says that a box filled with oranges, let me underline this in blue, a box filled with oranges is 50 kilograms. It says write an equation that you could use to find the number of oranges in each box. The question is, how many oranges did I throw in here to fill the box up if the whole box ends up weighing 50 kilograms? Well, let's break that up. We have a box, the weight of the box, plus a whole bunch of oranges. Lots and lots and lots and lots of oranges, right? Do I know how many oranges? No, and if you're counting, stop it. Don't count anymore. I have a lot of oranges that I'm going to be throwing into this box. And that's all going to equal the 50 kilograms here. I know how much each orange weighs, and I know how much the box weighs. The box weighs, right here, the box weighs 10 kilograms. Plus, how many oranges are there? That's the unknown, guys. Read the question again. Does it ever tell me how many oranges are there? Well, that's the unknown. Pardon me for not using O for a variable. I am going to just use X because O can be misinterpreted as a 0. So I'm going to use X as my variable for how many oranges there are. Okay. How much do the oranges weigh, though? Well, that's given right about here. Each orange weighs 0.2 kilograms. Get rid of this K. So I got 10 kilograms plus the 0.2 kilograms multiplied by the how many oranges there are is going to be 50 kilograms. And that's my equation, guys. It's that simple. So let's take a look at the parts and make sure I've got everything covered. We know that this is the weight of the box. This term right here is the weight of all the oranges. So what I have again, sorry, the video keeps cutting out on me. What I have left is I have the box plus the weight of all the oranges. All the oranges here, because it's 0.2 is the weight of the oranges times the amount of oranges is the weight of all the oranges, and that's going to equal the total weight here of the box with the oranges. And it works out. I have my equation, 10 plus 0.2x equals 50 kilograms. So guys, that's it. That's how we write equations given some word problems. Now let's look at some nastier problems here. I'm just going to skip this guy. Let's take a look at this one. This one is not necessarily nasty, but they can kind of be kind of confusing to read. So let's just take one of these at a time. Let's take a look at A. 7 more than twice the number is 17. Well, which one of these equations up here at the top, which one of these equations will fit into each of these boxes? Well, this one, let's set up this first one in A the best we can. 7 more than, we're probably going to be using addition. Twice a number. Well, how do you find twice a number? Well, you times it by 2. What's the number? I don't know. The number is unknown, so we're going to use a variable. And then I have 7. Don't get confused by the way this is worded. We want more than twice the number. So actually, I'm going to start with 2x, but I want 7 more than 2x. And lastly, we talked about this earlier, is a word for equals. So that's going to be equals 17. Go ahead and try out this next one, B, and see which one of the ones up top, one of these equations up top will fit for B. All right, so the product of 2 and a number increased by 17 is 7. Remember, is a word for equals, so is 7. The product of 2 and a number, product meaning multiply, of 2 and some number, that means we're going to be multiplying 2 times some number, 2x, let's say, increased by 17, increased, coming from, probably going to mean plus here. I mean, we don't increase by subtracting stuff. we're going to be doing 2x plus increase by 17 equals 7. Go ahead and give C a shot. The difference between twice a number and 7 is 17. Now this one can get a little tricky. The difference, meaning subtract, between twice a number, that's that 2x again, and 7. This is going to be 2x minus 7 is equals 17. Give this one more shot. D here. 17 less than twice the number is 7. This one's a little trickier because we want less than twice the number. So I want to start with twice the number and then take away 17 from it. Because if you were 3 years older, less older than me, then you're going to take my age, the bigger number, minus yours. So if I wanted 17 less my age, I would do my age minus 17. In this case, I want to go twice the number is that equals, so equals 7. 17 less than that of this twice number would be 17. The less than is still minus, but watch out for that order. It's going to be actually 2x minus 17. And that one's probably the trickiest of them all. So be careful with those ones. And that's all, guys. Let's just stop the word problems there. Hopefully you guys can write two-step equations from word problems now. And we'll give some more practice at this tomorrow in class.